This is the assignment solution for the operation and planning of power distribution system week 2 of 2025 year. So if this question is asked like this, so a feeder has 10 nodes and among these are 5 residential, 3 industrial and 2 are commercial loads. The load maximum demand of the load is like 40, 120 and 100 kilowatt respectively for residential, industrial and commercial consumers. The total energy consumption of the feeder is 600 units on the same day, with 15% losses occurs due to ohmic losses. So if the residential loads consume 20% of the total feeder consumption, find the load factor of the residential load. So the calculation or the solution is like this: average load is equals to 600 units and 20% consumption for the residential, so it is 120 units, that is 120 kilowatt hour, divided by 24 will give us the value of the load, kilowatt. So 5 kilowatt is the average load. Now load factor for the residential is the average load upon maximum demand. So average load is 5 and maximum demand is 40, so it is 0.125 is the answer. So here option 1, 0.125 is the answer. See, 40 is the maximum demand of residential consumer. Second, now if the connected load on commercial load is 900 kilowatt, find the demand factor. So demand factor can be calculated like this, that commercial load is 900 kilowatt, so peak load demand is 100 and the connected load is 900, so it is 0.1111 is the answer. See this, the industrial load is 120 and commercial is 100. So for commercial load, 100 divided by 900 is equals to 0.111. Now if the peak load demand of the feeder is 180 kilowatt, the overall diversity factor of the feeder is calculated. So peak diversity factor is the 180 kilowatt is given, 180 is the peak load demand of the feeder, overall is, and the total connected load maximum demand individual, that is non coincidence value of the demands, is 40 for residential, 120 for industrial and 100 for commercial. So 100 plus 120 plus 40 divided by 180 is equals to 260 by 180, that is 1.4444. So the answer is C, 1.445. Now fourth is, if the feeder energy loss during the peak hour is 18 units, so peak demand of the feeder sustains for 20 minutes, determine the feeder loss factor. So loss factor is calculated like this. So it sustains for 20 minutes, so it is 1 by 3 hours, and the energy loss during this is 18 kilowatt hour. So energy loss is 18 kilowatt hour. So for the 20 minutes or 1/3 of the hours, we can calculate the power loss is 6 kilowatt. Now first of all, 15 kilowatt energy loss, that is 600 into 0.15, that is 90 units per day. So average power loss is 90 divided by 24, that is 3.75 kilowatt. Now loss factor is equals to average load, that is 90 divided by 18 is the peak load loss, that is peak load 18 divided by 24 is the total number of hours of the day, so it will give us 0.2083, and we went to find for 20 minutes, that is we have to divide it by 3. So 1/3 is multiply, or say 20 minutes is divided, so it will give us 0.06944 is the value. So option is D, 0.0694. Now the area under the load curve represents the energy consumed, so it is D is the right answer. Now a power station has the maximum demand of 1500 kilowatt, load factor is 50% and plant capacity factor is 40%. The reserve capacity of the plant can be calculated with the help of this. So load factor is equals to average load upon maximum demand, so average load is equals to 0.5 into 1500, so it is 750 kilowatt. Now plant capacity factor is equals to average load upon plant capacity, so plant capacity is equals to average load, we have already calculated, that is 750 divided by 0.4, so it will give us 1875 kilowatt. Now reserve capacity is equals to plant capacity minus actual maximum demand, So 1875 minus 1500 is equals to 375 kilowatt is the reserve capacity of this plant. So answer is C. Now which one of the following is or are correct? Now here it is not round, so multiple answers can be right in case of square options. So one is load factor is less than 1, demand factor is also less than or equals to 1, diversity factor is always greater than 1, and coincidence factor is less than 1. So option B and D are correct. Now for the question 8 to 10, they are common data question, and the graph is here drawn for the basic understanding purpose. So it will supplied by the one generating unit of 40 megawatt and two generating unit of 30 megawatt each. So total generating capacity is 40 plus 30 plus 30, that is 100 megawatt. Now we have to determine the load factor. So load factor can be calculated with this average load, that is area under the load curve. So this is the area. So this is the triangle 80 and 260 is the triangle area. This is the square 40 60 is a square, and it is again a triangle, and then there are one rectangle and one square. So this is how the area of this triangle plus this rectangle plus this triangle plus this rectangle plus this rectangle, summation of all the areas will give us the average load consumption. So I have done the same here for the area under the triangle plus square plus triangle plus square divided by total number of time, that is 8760 hours of a year. So this is how we have calculated 68.2648 megawatt is the average load on the feeder. So load factor is now average load upon maximum demand, and maximum demand is 100 megawatt. So it is 0.6826 is the load factor. So option B is the right answer, 0.683. Now we have to find out the plant capacity factor. So plant capacity factor is average load upon plant capacity. So average load is 68.2648 and plant capacity is 100. So 68.2648 divided by 100 is equals to 0.6826. So the answer is 0.6826. Yes. Now third is determine utilization factor. So utilization factor can be calculated is maximum demand upon rated capacity. So maximum demand is 100. Yes, installed capacity is 100 and the maximum demand is 0.6826. So 68.2648 divided by 100 is equals to 0.6826, and if we rounding off this, so it is nearly 0.7. So I have taken B is the right answer or option. Now I am submitting the assignment. The answer that I have submitted right now is as per the best of my knowledge. So I have now submitted and the answer is recorded.